Dear learners, welcome to MSBT online learning platform, MSBT Lead Learning at Your Doorsteps. I am Mrs. Sonali Sharigar, lecturer at Agnem Polytechnic, Navi Mumbai. Unit 5 of this course is Applications of 8051 Microcontroller, and the unit outcome is Control the given parameter using 8051 microcontroller. The learning objective of this presentation is develop program for DAC to generate square wave. At the end of this presentation, you'll be able to develop an assembly language program for DAC to generate square wave. Let us see what all things you're going to learn in this presentation. I will first introduce you to DAC 0808. You will learn how to interface DAC with microcontroller 8051, and you'll also be able to develop a program for generation of square wave. This is a concept map. Microcontroller 8051 outputs 8-bit digital data to DAC. DAC converts this 8-bit digital data to analog form. DAC 0808. Dear learners, you have learned about DAC 0808 in Unit 4. We know that DAC 0808 is an 8-bit DAC. It consists of 8 digital input, A1 to A8, where A1 is MSB bit and A8 is LSB bit. DAC 0808 converts this digital input in current form. This analog current is converted to analog voltage form by using an current to voltage converter. The output current generated by the DAC 0808 is given as V reference upon R14, which gives us the reference current, multiplied by A1 by 2 plus A2 by 4 plus A3 by 8 plus A4 by 16 plus A5 by 32 plus A6 by 64 plus A7 by 128 plus A8 by 256. Thus, the output voltage generated by the I to V converter is output current multiplied by the feedback resistance. Let us see how to interface DAC 0808 with microcontroller 8051. As you can see in this diagram, the DAC digital input pins A1 to A8 are connected to port 1 pins of microcontroller 8051 such that the MSB bit of digital input pin of DAC is connected to MSB bit P1.7 of port 1, and the LSB digital input bit A8 of DAC is connected to LSB bit of port 1 P1.0. When microcontroller outputs data on port 1, it gets sent to the digital input pins A1 to A8 of DAC, which converts this digital input into analog current form, which in turn gets converted to analog voltage by I to V converter. Let us see when we give digital input to the DAC what happens. What if port 1 outputs data 00H? As port 1 data is 00H, all the 8 pins of port 1 are logic 0. This data is given to A1 to A8 pins of DAC. As a result, the output current of DAC is V reference upon R14. We have kept V reference as 5 volt and R reference, which is R14, as 2.5 kilo ohms. And the bracket term, all the bits A1 to A8 of DAC are 0. So bracket term is 0. So the output current is 0 milliamperes, and the output voltage thus generated by the DAC is I0 into RF. As I0 is 0 milliamperes, the output voltage is 0 volts. What if now 8051 is programmed to output data FFH on port 1 pins? Means all the pins of port 1 output logic high, and all the digital input pins of DAC A1 to A8 are getting logic high. As a result, the output current of the DAC is 2 milliamperes multiplied by 1 by 2 plus 1 by 4 plus 1 by 8 so on plus 1 by 256, and we get the output current as 1.99 milliamperes, and the output voltage, which is equals to I0 into RF, which is 1.99 milliamperes into 2.5 kilo ohms, comes around 4.97 volts, which is approximately equal to V reference of the DAC. Thus, DAC generates analog output voltage from 0 volts to 5 volts. With DAC interface to 8051 to generate a square wave using DAC, 8051 is programmed to output data 00H and FFH alternately with a certain delay in between. Let us understand the program to generate square wave. As we know that to generate a square wave, 8051 has to output data FFH and 00H with a certain delay in between. The first instruction move P1, hash 00H sends the value 00H to DAC. As a result, the analog output voltage of DAC is 0 volts. Then instruction A called delay calls a delay subroutine. As long as this delay subroutine is getting executed, the data on the port 1 is 00H, which means the DAC analog output is 0 volts. After delay subroutine is over, move P1, hash 0FFH instruction sends value FFH to DAC. As all the digital inputs of DAC are logic high, the analog voltage output of DAC is 5 volts now. Again, a delay subroutine is called. As long as delay subroutine is getting executed, the DAC analog output voltage is 5 volts. Once the delay subroutine execution gets over, S-jump instruction repeats the whole process again to generate a continuous square waveform. The delay subroutine used is generated by using registers of 8051. Now let us simulate the DAC program. As you can see on your screen in Keil Microvision IDE, the DAC program is written. Let's build a target. We get 0 errors, 0 warnings, and even a hex file is created. Let us debug the program now. Here you can see port 1 window is open. Also the logic analyzer window is seen. Now when you run the program, you can see that port 1 pins are outputting FFH and 00H alternately with a certain delay. And when you see it in logic analyzer, you can see it as a square wave. The on time and off time of the square wave is decided by the delay which is given between data FFH and 00H. Now if you want to see if this program can work in hardware, in the circuit simulation software, I have connected a DAC to the port 1 of microcontroller 8051. If you can see, the current output of DAC is converted to voltage by using an I2V converter, and a CRO is connected to the output pin of I2V converter. The program is burned into the IC, and when you run the simulation, you can see square wave getting generated. Also, if you see the output voltage getting switched between 0 and 5 volt continuously. Dear learners, attempt MCQ set 1. Thank you.